Our universe is vast. It's filled with billions of galaxies, each teeming with stars and planets. But what if our universe isn't the only one? What if, hidden from our view, there exist other universes, each with its own unique laws of physics, its own history, and its own possibilities? This is the mind-boggling concept of the multiverse, an idea that has captivated scientists, philosophers, and science fiction enthusiasts for decades. The multiverse is not merely a product of our wildest imaginations, and it arises from some of the most profound and well-tested theories in physics, including quantum mechanics, cosmology, and string theory. The possibility of a multiverse challenges our understanding of reality itself and forces us to confront the limits of what we can know. The idea of a multiverse is not new. Ancient Greek philosophers like Chrysippus pondered the possibility of an infinite number of worlds, each with its own unique configuration of matter and energy. However, it was only in the 20th century, with the advent of modern physics, that the concept of the multiverse began to take on a more concrete and scientific form. In the sections that follow, we will delve into the tantalizing possibility of a multiverse, exploring the scientific theories that support it, the challenges in proving its existence, and the profound philosophical implications it raises. The idea of a world beyond our own has captivated human imagination for centuries. Ancient Greek philosophers, known for their love of logic and reason, were among the first to systematically explore the possibility of multiple universes. Chrysippus, a prominent Stoic philosopher, argued that an infinite universe would necessitate the repetition of worlds, including our own, an infinite number of times. While lacking the tools of modern science, these early thinkers grappled with profound questions about the nature of reality and the possibility of other worlds. Their musings laid the philosophical groundwork for the multiverse theories being explored today. The concept of multiple universes remained largely in the realm of philosophy and speculation for centuries. It wasn't until the 20th century, with the birth of modern physics, that the multiverse began to emerge from the shadows of philosophical thought and into the light of scientific inquiry. The development of quantum mechanics, a theory that describes the strange and counterintuitive behavior of matter at the subatomic level, would prove to be a pivotal turning point in the quest to understand the multiverse. In the early decades of the 20th century, physicists like Erwin Schrödinger and Werner Heisenberg revolutionized our understanding of the universe with their groundbreaking work on quantum mechanics. Their theories revealed a universe far stranger than anyone had imagined. A universe where particles could exist in multiple states at once, where the act of observation could alter reality, and where the very fabric of space-time could be a turbulent sea of quantum fluctuations. It's from this strange and wondrous world of quantum mechanics that one of the most compelling arguments for the multiverse arises. Erwin Schrödinger, an Austrian physicist, is best known for his famous thought experiment involving a cat in a box, a thought experiment designed to illustrate the bizarre nature of quantum superposition. Schrödinger's equation, a cornerstone of quantum mechanics, describes how quantum systems evolve over time. However, this equation presented a perplexing dilemma. It suggested that particles could exist in a superposition of states, meaning they could be in multiple places or have multiple properties simultaneously. This idea of superposition was deeply unsettling to many physicists, including Schrödinger himself. How could a particle be in multiple states at once? It seemed to defy common sense and our everyday experience of the world. To illustrate the absurdity of superposition when applied to the macroscopic world, Schrödinger devised his famous thought experiment. He imagined a cat sealed inside a box with a device that had a 50% chance of releasing a lethal poison. According to quantum mechanics, the cat would exist in a superposition of states, both alive and dead, until the box was opened and the cat's state was observed. While Schrödinger intended the thought experiment to highlight the strangeness of quantum mechanics, it inadvertently opened a doorway to the multiverse. If particles could exist in multiple states simultaneously, perhaps the universe itself could exist in multiple states, branching off with each quantum measurement or interaction. This interpretation of quantum mechanics, known as the many worlds interpretation, would become one of the most compelling arguments for the existence of a multiverse. In the late 20th and early 21st centuries, physicists and cosmologists began to explore different models of the multiverse, each with its own unique characteristics and implications. One of the most influential classifications was proposed by Max Tegmark, a Swedish-American physicist at MIT. Tegmark's classification system divides the multiverse into 4 levels, each building upon the previous one in terms of scope and strangeness. Level 1, the simplest level, is an extension of our own universe. It suggests that our universe is infinite and that, due to the finite speed of light, we can only observe a small portion of it. Beyond our cosmic horizon, there may exist regions of space-time identical to our own, containing copies of ourselves and everything we know. Level 2 arises from the theory of cosmic inflation, which posits that our universe underwent a period of exponential expansion in the first fraction of a second after the Big Bang. According to this theory, different regions of space-time could have inflated at different rates, giving rise to bubble universes with different physical constants and laws of physics. Levels 3 and 4 delve into even more mind-boggling territory. Level 3 is the many worlds interpretation of quantum mechanics, where every quantum measurement causes the universe to split into multiple universes, each representing a different outcome. Level 4, the most speculative and controversial level, proposes that the multiverse encompasses all possible mathematical structures, even those that defy our current understanding of physics. These 4 levels illustrate the vastness and diversity of the multiverse concept, ranging from relatively straightforward extensions of our own universe to realms of existence beyond our wildest imagination. Section 5. The Many Worlds Interpretation. A closer look. The Many Worlds interpretation of quantum mechanics, first proposed by Hugh Everett III in the 1950s, stands as one of the most mind-bending and controversial concepts in modern physics. Unlike other interpretations of quantum mechanics, which struggle to explain the transition from a superposition of states to a single observed outcome, MWI embraces the idea of superposition on a cosmic scale. According to MWI, every time a quantum measurement is made, or every time a quantum system interacts with its environment, the universe doesn't choose one outcome over another. Instead, the universe splits into multiple universes, each representing a different possible outcome. Imagine, for instance, flipping a coin. In the everyday world, we expect the coin to land on either heads or tails. However, according to MWI, both outcomes occur. The universe splits into 2 parallel universes, one where the coin lands on heads and one where it lands on tails. This process of branching occurs constantly, creating an unimaginably vast and complex multiverse. Each universe within this multiverse represents a different history, a different timeline, and a different set of possibilities. While MWI elegantly addresses some of the puzzles of quantum mechanics, it also raises profound philosophical questions. If every quantum measurement creates a new universe, then what does it mean for our concept of free will? Do our choices have any real consequences, or are all possible outcomes playing out in some parallel universe? These are just some of the tantalizing and deeply philosophical questions that the many worlds interpretation forces us to confront. Section 6. Searching for echoes in the cosmic microwave background. While the multiverse remains a largely theoretical concept, scientists are actively seeking observational evidence to support or refute its existence. One promising avenue of investigation lies in the study of the cosmic microwave background radiation. The CMB is a faint afterglow of the Big Bang, a thermal radiation that permeates the entire universe. It provides a snapshot of the universe as it existed just 380,000 years after the Big Bang, long before stars and galaxies formed. Cosmologists believe that the CMB might contain subtle imprints or anomalies that could provide evidence of collisions or interactions with other universes. These imprints could take the form of temperature fluctuations or patterns in the polarization of the CMB. Several research groups have claimed to have found evidence of such anomalies in the CMB data collected by satellites like WMAP and Planck. However, these claims remain highly controversial and are still the subject of intense scrutiny and debate within the scientific community. While the search for observational evidence of the multiverse continues, It's important to note that the absence of such evidence wouldn't necessarily disprove its existence. The multiverse, by its very nature, could be hidden from our view, separated from our own universe by vast gulfs of space-time or by barriers that our current understanding of physics cannot penetrate. Section 7. The challenge of verification. The multiverse theory, while captivating, faces a significant hurdle: verification. The very nature of the multiverse, with its possibility of existing beyond our observable universe, makes it incredibly challenging, if not impossible, to directly observe or interact with these other universes. This limitation has sparked debate among scientists about whether the multiverse theory falls under the realm of science or philosophy. Traditional scientific theories rely on testable predictions and falsifiability. If a theory cannot be tested or disproven through observation or experimentation, it's often argued to fall outside the boundaries of empirical science. The multiverse, with its potential existence beyond our reach, challenges this traditional view. However, proponents of the multiverse argue that the lack of direct observation doesn't render the theory unscientific. They point to the fact that many accepted scientific theories, such as the theory of evolution or the theory of plate tectonics, deal with phenomena that cannot be directly observed in a laboratory setting. Instead, these theories are supported by a convergence of evidence from various fields, and their predictions have been consistently borne out by observations. Similarly, multiverse proponents believe that while we may not be able to directly observe other universes, we might be able to find indirect evidence of their existence by studying the after effects of their interactions with our own universe. This evidence could come from anomalies in the cosmic microwave background radiation, as mentioned earlier, or from subtle variations in the fundamental constants of nature. Section 8. Between science and philosophy. The multiverse theory occupies a fascinating and somewhat ambiguous space between science and philosophy. On the one hand, it arises from some of the most well-established theories in physics, such as quantum mechanics and cosmology. On the other hand, it pushes the boundaries of what we can currently observe and test, leading some to question its scientific validity. Critics of the multiverse theory often argue that it's more of a philosophical concept than a scientific one. They point to the lack of direct observational evidence and the difficulty in devising testable predictions as reasons to view the multiverse with skepticism. They argue that invoking the multiverse as an explanation for certain phenomena can lead to a multiverse of the gaps fallacy, where any unexplained observation is attributed to the existence of another universe, stifling further scientific inquiry. However, proponents of the multiverse theory counter that the absence of direct observation doesn't render a theory unscientific. They argue that many groundbreaking scientific theories, such as the theory of atoms or the theory of relativity, were initially met with skepticism and resistance because they challenged prevailing scientific paradigms. They believe that the multiverse theory, while speculative, has the potential to revolutionize our understanding of the universe and our place within it, much like these earlier revolutionary theories. The debate over the scientific status of the multiverse is likely to continue for many years to come. It highlights the evolving nature of science itself and the challenges in defining the boundaries between what we can know and what remains beyond our grasp. Section 9. A tapestry of possibilities. The multiverse theory, while still in its infancy, has captured the imagination of scientists and the public alike. It challenges us to expand our view of reality and to confront the possibility that our universe, vast as it is, may be just one small part of a much grander and more complex cosmic tapestry. Whether the multiverse exists or not remains an open question, a question that may remain unanswered for generations to come. However, the very act of asking such a question, of pushing the boundaries of our knowledge and imagination, is a testament to the enduring power of human curiosity. The multiverse theory, regardless of its ultimate validity, has already enriched our understanding of the universe and our place within it. It has sparked new avenues of research, challenged our assumptions about the nature of reality, and forced us to confront the limits of what we can know. In the end, the search for the multiverse is not just a search for other universes, but a search for ourselves, a search for our place in the grand scheme of existence. And that, in itself, is a journey worth taking.